For number 6, once again, we're asked to find out where the function has increasing or decreasing intervals and where it has relative maxes or mins. So we're going to find the first derivative. The first thing I'm going to do is I'm going to rewrite the function by bringing x squared to the top of the fraction. I'm going to make this to be x to the negative 2 power. And we're going to take the derivative of that. We're going to multiply the front by negative 2. We're going to reduce the power by 1. And I'm going to rewrite the first derivative with only positive exponents. We're looking for two things. We're looking for where the first derivative is 0 or where the first derivative is undefined. Let's set the first derivative equal to 0. And we're going to write 0 as a fraction. We're going to cross multiply. So we get 0 equals negative 2. And we said if we get a false statement without a variable, then we said whatever we were looking for, there are none. So there are no x values that will have that will give the first derivative 0. And where's the first derivative undefined? If we look at our denominator, set it equal to 0. The only way that x cubed, that denominator, could be 0 is if x equals 0. So x equals 0 will separate our graph into two intervals. From the left, I'm going to choose -1, and then from the right interval, I'm going to choose a positive 1. We're going to plug them both into the first derivative. And so to the left, I'm putting in a -1. We get negative 2 divided by x cubed, negative 1 cubed. So that would be negative 2 divided by negative 1 cubed would be negative 1, so we get a positive 2. So since the slope here is positive, we know we're increasing from left to right on the left side of 0. And we're going to put in a positive 1 into the derivative as well. Okay, here we see that the numerator will be negative, denominator will be positive, so we end up with a negative slope. And if the slope is negative, then we're decreasing as we go from left to right on the right side of 0. So the graph is increasing from negative infinity to 0, and then decreasing from 0 to infinity. And what about a relative max? So it looks like it's increasing from the left and decreasing to the right, so it could be potentially a relative max. But what happens when we put 0 into the function? When we put 0 into the function, that's 1 over 0 squared. That's 1 over 0. We get a value out that's undefined. So at x equals 0, we actually have an asymptote there. So there's no actual point on the graph where that transition occurs from increasing to decreasing. There's an asymptote there. So we have no relative maximum, because remember that we have to have a legitimate point on the graph that we can say it's higher than any point that's to the left or to the right of it. Since there's an asymptote there, then this is not a point on the graph. So there is no point on the graph at x equals 0. So therefore no relative max. And we also had no relative minimum.